JavaScript. I think Matt, where are you now? Okay, JavaScript, or at least relaying some of the questions. And then Chris is going to be our meeting minute taker. Thank you, Chris. And thank you, Matt. We'll pass the blue sheets around as well. Okay. So you know the note well. I took care of this as well. So let me go straight into the status update before I go into the agenda. Eckhard, maybe you want to say some words directly regarding the documents since you looked at them. We had a discussion before the meeting.
I guess I'm supposed to say Eric Rescorla, AD for this group. So there are 5 documents which have made it out of the working group and are in some various state of like unpublication. The first is JWT BCP. I sent a review of that, I think in August. So I'm waiting for a revised version. Mike tells me he's working on it, so I assume that will be impending. I sent a review of MTLS this morning, so I'm expecting a revised ID. If people want to chat about the review, I'm happy to do that. Sorry, was so close before the meeting. Okay. In any way, I defer to the chairs and how they want to manage that. Let me just run through these and then we can talk about the logistics. The token exchange document is on the November 21st telechat. So everything seems fine there. It's just got to be, telechatted. The device flow document has been approved by the IESG. There were a big pile of comments. So I've asked the chairs to go through the comments and basically tell me which ones they think they've addressed or which ones they have not addressed and why. That just makes it a lot easier for me to make sure that things have been properly handled. None of this should be blocking. But they're like, typically I do want people to take ISG comments seriously. And then the last one is JWS rec, which for no obvious reason has been an approved announcement to be sent for 200 days. Maybe it's me, but we can't figure out why it would be. So I've emailed the secretariat and asked them to send the approved announcement. It's approved. Well, as Ben points out, I guess it's not approved till the message is sent, but as far as I'm concerned, it's approved. So that should be fine. So I don't know how you want to handle the TLS stuff, the MTLS stuff. I sent a long review. If people want to talk about the next meeting, that's fine, or whatever. Honestly, really, chair here.
Yeah, I think it would make sense to go through the comments in a small group and then see whether we have some questions back for you during this week. I think it's definitely something we want to submit an update with some of the comments that are sort of low-hanging fruits, and then see whether there's something bigger that we need to maybe discuss tomorrow. So maybe having a short conversation today would be useful. Also, as I said, for the device flow, we would have to go through the resolved comments and then see which ones got resolved by which text proposals in the document to get this finalized and get this out of the door. So I guess after this meeting, we'll sit together and figure out what useful.
So one thing I've found helpful sometimes is if you guys want to sit down with the device flow document and just walk through the comments. Well, that too, either one. But the device flow, basically, Richard and I did Acme the other day, and what we did was we just pasted the Google Doc, and then we just went through them one at a time. And like Richard would say, well, this is dealt with, and this is dealt with, and this is why. And then, so if you want to write me an email or a GDoc or whatever, that's fine. But I'm happy to sit down and do it manually. It takes about 20, 30 minutes. It just turns out to be like really, really hard for the AD themselves to go through and track all the mailing list traffic. And so the people who did the resolution, it's easier for them to say, this is what I did and why I didn't do it, or whatever. So I'm happy to make time for that if at the author's or chair's decision.
Yeah. So I guess we'll, after this session is over, we'll sit together briefly to find out what would be a good time to do this type of things. How does that sound? Okay. And Did you mention the token exchange, Eka? He did. That was that was on the telechat. Okay, perfect. Yeah. Okay. Perfect. Good. I got some emails for agenda bashing, and so I restructured the agenda slightly. Brian's presentation on the token binding, OAuth token binding, was moved to the first presentation. And then we have Thorsten talking about the security topics, the JWT introspection response. Thorsten had submitted a proposal for discussing a financial API. And then I have at the end a presentation about the updated document on the Bob key distribution. That's the agenda for today. Tomorrow we'll continue. We have the resource indicators document, the MTLS, and Dick is going to speak about reciprocal OAuth and distributed OAuth. And then we have a remote presentation from Omar about the seamless flow. Okay, that's pretty much it with regard to the agenda. Is there any proposal for bashing the agenda, or another proposal for bashing it?
Just relaying for Aaron. Apologies for not submitting this sooner, but he has another one prepared for consideration, which is the OAuth browser-based apps.
Yeah, a good point. So a few of us met at IIW, I think it was 2 weeks ago in Mountain View, California, and we talked about different, well, as always there, I talked about different OAuth topics, and one of the sessions that Aaron led was on a BCP for browser-based apps, similar to what we have for the native apps. And he promised at that workshop to put a draft together, which he did. It's just, I think the gates are now open, he can submit it. And as soon as he's going to do that, we can have a look at it. And if he joins tomorrow remote, or I don't know, is he online now?
He is on Jabber right now, and it is submitted. It's in the Jabber chat room, the full URL.
Perfect. So that's something we could, if he has time, he could dial in or log in tomorrow and give a short update on that, give us a sort of a preview. Okay. Yeah, thanks Aaron for the quick reaction time. So let me...
Hannes, would you mind swapping these first two? Oh, MTLS is, okay, never mind. I was looking at Tuesday's agenda, not Monday's agenda, so never mind.
Okay, yeah. Yeah. Okay, Brian.
Hi, Brian.
Hello, everyone. We have slides. So I was just trying to ingest Ecker's review of MTLS this morning, right before this meeting. So I'm a little, try to switch context here and talk about MTLS, or talk about whatever the hell I'm talking about this morning. Token binding.
Good morning.
Good morning. There's a little jet lag in there too. Do we have slides?
Actually, normally we should. I don't know why it doesn't show the slides. Let me try.
There's something.
But it's not my machine.
Jeez, looks like it's
That's a
down.
nice logo.
It's the wrong machine. why we have problems here now.
Happens. Oh, welcome to Bangkok, everybody. All right, yeah, so as I try to set my own context here, OAuth2 token binding, do an update on that. And yeah, I'm trying to switch context, so bear with me a second. But here we go. Maybe. Is this not working?
Yeah.
Okay. You can just
Yeah, take that.
advance hold this for. All right, so I want to give a quick overview of token binding. The base layers just to sort of set some context about how the rest of this stuff works. So what token binding is, basically it enables a long-lived binding of cookies or other security tokens, specifically OAuth tokens in this context, to a client-generated public-private key pair. Use of this functionality is negotiated in the TLS handshake via TLS extension. And then what happens is after negotiation, on every HTTP request, proof of a key or keys is proven. Possession of those keys is proven by signing the TLS exported key material and a few other things, and sending that signature and the public key in an HTTP header on every single HTTP request. Cookies and other tokens, again, OAuth tokens, can be bound to that key, and then on issuance, and then the binding can be checked on subsequent use. And that proves that the presenter of the token holds the corresponding key that it's bound to. These keys are scoped to the effective top-level domain +1. So there's, particularly in the browser use case, there's some privacy implications around that, and they're not, the keys are only scoped basically equivalent to what you could scope a cookie for. They don't leak out and allow for tracking beyond that. And this idea of federated or cross-domain use cases outside of that scoping are supported by what's called the referred token binding, and that's in contrast to the provided token binding. The provided token binding is kind of the normal binding, the normal key that you use with a site directly. This idea of a referred token binding is a key that's used with a different site, with a different ETDLD +1. And under certain conditions, you can have that revealed to another site. You can set both of those bindings so that you can issue a token which is bound to the key that would be used with the referred site, and basically allow then token binding to a cross-domain case, bind a token that's issued for use at a different domain. And the ways that actually works right now is in the spec, there's this include referred token binding ID response header. And if that's sent on any HTTP 300 redirect, it tells the browser that it should reveal the token binding ID, the referred token binding ID that it used between itself and the site that's issuing the redirect, as well as the provided token binding ID that it's going to send to the target of the redirect. So typically you'll get a redirect with this, this ID to the token provider, the AS, and that in that redirect, that tells the browser or whatever, typically a browser, to reveal both of the token binding IDs when making that connection. That allows the AS to bind the token to the referred ID. And then also in the implementation considerations, there's sort of some weasel language around here that says token binding implementation should provide APIs that generate token binding messages containing token binding IDs of various application-specific token binding types to be conveyed by the SEC token binding header. Basically, it's just saying for general purpose APIs that do token binding, there should be some mechanism in the API to signal to that when to include a referred token binding ID or other types, but specifically referred in the request, so that the application itself can control when to send the referred and allow for whatever the receiving party of that request can bind to the referred token binding ID. So those are kind of the two ways that you can right now reveal the referred token binding, either through this redirect mechanism or through some client-provided API in whatever language you're using to develop the functionality and make the actual HTTP requests. And this would be on the OAuth client, basically, it's making these requests. Next slide, please. Really smooth. Thank you, Hannes. So then a quick overview of OAuth token binding, building on that functionality. We have OAuth2 token binding, and this provides an OAuth2 proof of possession mechanism based on token binding that basically prevents replay or cross-play of stolen or lost tokens. There's a couple of different things it does. One, and maybe the most interesting, is binding access tokens using that referred token binding ID. And there's functionality specified or described in the draft that allows for binding access tokens that are issued from the token endpoint through normal grant type. Any grant type you send to the token endpoint, you can bind that way. And then also for access tokens issued from the authorization endpoint via the so-called implicit flow. We provide a mechanism to represent this binding in an access token if it's a JWT through a confirmation claim that with a TBH member, that's just shorthand for token binding hash. And basically it's just a hash of the token binding ID, and that token binding ID is in effect the public key that's generated on the client. There's some mechanisms describing how you'd bind a refresh token, how you'd use Pixie to do binding of the authorization code that are effective both for native app clients and web server clients. The mechanisms are a little bit different. And then just because we could, really, there's some language in there describing how to bind JWT authorization grants and client authentication. So to take those mechanisms that we already have described and add a confirmation claim in there and bind those to the token binding key in the TLS layer. That's the draft in a nutshell. Next slide, please. So some things that have happened, notable happenings since Montreal. I'm sorry, I can't see my own writing very well. Actually, just prior to Montreal, a question was posed to the list, and basically the thrust of it was that it's not very clear how an access token issued from the authorization endpoint, the implicit flow access token, is actually token bound. Had a little conversation about that, but it's a valid question. AS metadata went to RFC 8414 and established a registry, which we've been waiting on for a while. Unfortunately, a widely used web browser decided to drop its support for token binding, which unfortunately I think is a major development towards the long-term sort of viability and usability of this stuff. It's not the end for sure, but it's certainly a blow to it. The token binding protocol, negotiation, and HTTPS, so the core functionalities described in 3 different drafts all went to RFC. And then I published draft 8 of OAuth2 token binding, and basically all it did was update references to the RFC versions of AS metadata and the 3 core token binding specs. And then not long after that, I got a question off the list, but it was more or less the same question that was the first question up there, which is don't really understand how the token binding ID of the RS is determined using this implicit flow. So a bit of a thematic issue in terms of the questions that have been coming up around how that works. Next slide, Hannes. So how does token binding of an access token in the implicit flow work anyway? And the truth is it doesn't work very well and it's a little bit awkward. But this would be intended for an OAuth client that is running as script, JavaScript in the user agent. And the AS is going to bind the access token to the referred token binding that is sent to the authorization endpoint in the authorization request. And that's the token binding between the user agent, where the client is residing and running, and the protected resource or API or resource server, whatever you want to call it. In that request, the include referred token binding ID response header on an HTTP 300 redirect is the only way currently within the browser landscape, assuming the browser even supports it, but if it does, to have the browser send the referred token binding to the authorization endpoint. What this implies then is in order for this flow to work for token bound access tokens through the authorization endpoint, there has to be some HTTPS request from the browser in a full page context to some endpoint or resource at the protected resource server, which in turn gets full page redirected to the authorization endpoint with a properly formed authorization request at the authorization endpoint there at the AS. And so that has to include the client generated state, the client ID, the proper response type, the correct redirect URI, if in fact that's applicable there, and whatever else you need in a proper authorization request. Another awkward bit of this, not specifically related to OAuth, but when you combine it with OpenID Connect, which has the concept of token-bound ID tokens for login, cross-domain login, there's some oddities that come up as well. In particular, the token and ID token response types don't really work together because you get tokens issued for different parties that are bound to the token binding ID that isn't going to work in one context or the other. So if you have the forum post response mode, the access token will have the wrong binding. It'll be bound to the token binding ID between the client, the user agent, and the client, but it's actually being delivered to the client, so it can't be used, basically. If you have the fragments response mode, the token binding ID doesn't really make sense for the ID token, since there's no channel it's being delivered to on a request. It's just being delivered directly back in the response to the client, unless it's somehow passed to the client's backend. And also then the bound access tokens are used to call protected resources that happen to be in the same ETLD, effective top level domain +1, as the client backend. So it's a little bit awkward. Basically, token binding, when you're doing it together, token binding ID tokens and access tokens doesn't really work in this particular response mode. It's just one sort of awkward variant of a use case that's not particularly well understood. Get a better one, maybe. I hope. Next slide, though, in a minute. The off-list answer to the question happened to be Torsten, and in the course of explaining and discussing it, he worked up this flow diagram to help understand exactly how it would work to get access tokens bound when issued from the authorization endpoint, and it might be helpful to just sort of walk through it and look at it visually. Basically, you have the user agent and the client. They're shown as different lines here, but they're running together. So the client is executing a script inside of the user agent. Something happens. The client then directs the browser to make this request in a full page context to some endpoint at the resource server that says, hey, please direct me over to the AS. And it includes its state and probably also its client ID and other things to tell it how to form that authorization request. As a result, the resource server then does a full page redirect to the authorization server with state, whatever, for the authorization request and the include token binding ID header. That redirects over to the authorization server with an authorization request and the referred token binding ID because of that header that told the browser to reveal it. Normal stuff happens, authenticate, approve, etc. And then the authorization response comes back with the state the same and an access token that has been bound to the referred token binding ID. And you can turn around and the client can use that then to access resources at this resource server or really any resource server in that effective top level domain +1. And it's the onus then is on the resource server to check the token binding at that point. I don't know. I think it helps some to sort of visualize it this way, but basically it's really awkward because of the steps required to kick off the flow to make things happen such that the authorization can actually do the binding. You have to do some rather awkward steps sort of through the course of 2, 3, and 4 here to make that even possible. Next slide, please. So it led me to the question of what, if anything, we should be doing about token binding and the implicit flow. And I don't really know, but I wanted to pose a few questions up here. The first thing would be just leave it as it is now and let people figure it out on their own, or not, as seems to be the case so far. Like it hasn't really, people have had trouble figuring it out. Another thing would be to attempt to add some sort of explanatory or cautionary text about how it works and what would be needed or at least required to kick off the flow to actually get it to happen, basically explaining what was just explained in the previous slides and the emails around it that have come up. And then from there, at least give people the tools to understand what's necessary or what is and isn't possible, and then sort of leave it up to them to figure it out. We could also try to standardize some kind of flow that starts with, a client in the browser making an XHR or fetch request to a protected resource, gets some sort of response, and then figures out how to request some other resource at the RS with a full page HTTP request that in turn is redirected somewhere at the protected resource, which is in turn redirected somewhere to the authorization server with a fully formed authorization request, the referred token binding header, and then all the other stuff you need, including state, client ID, response type, redirect URL, and so forth. We could do that. It seems super, super awkward to try to put into spec language. There's a lot of discovery problems. Where would you even tell the client about this special resource at the RS? How do you ensure that the client can make the request to the RS that appropriately results in the kind of authorization request that it wanted, et cetera? So I'm not really proposing that we do this, but it's out there. It's something we could try to do. I'm not sure it's wise. Sure. Torsten.
Torsten, yes.com. Just one question.
Speak.
Just wanted to have your attention. Option 3, more or less, is the pattern that we would propose for native apps, or any kind of OAuth client that first discovers the, issues a pre-flight request to the resource server to obtain the token binding ID, which is then used in the request to the authorization server to make that mint and access token, which is bound to that refer token binding.
Option 3 is sort of like a pre-flight kind of request, sort of, to get the whole flow started with the right pieces in the right places. But I think it would only be applicable to browser-based clients. You wouldn't need to do, and probably couldn't even do any of this stuff in native clients. It's strictly for implicit type clients, script in the browser, SPA type clients.
Okay, then I would suggest to also add some text to the spec to describe how this is supposed to work for web apps and native apps. So how they are supposed to determine the token binding ID of the resource server before they actually invoke the authorization flow. You know what I mean?
I know what you mean, and I think it's in there, although perhaps it could be more clear. That would be through like a code flow, and there's a discussion about how the native client should or could get the referred token binding in making the request to the token endpoint. So
okay, I give it a read.
It could probably be better, but it's covered.
Mike Jones, Microsoft. Is part of the issue that there's not a standard token binding API for fetch? I know that Anand at Google and Jeff Hodges, now also at Google, had worked on a pull request in the WG to try to get that done, but I don't know the status of that now.
I'm not sure how to answer that because it depends on what such a fetch API might provide. I think that depending on what it is, the issue still exists for requests to the authorization endpoint. But if there was a proper API in place around fetch that you could have a JavaScript client call the token endpoint directly and send the referred token binding ID, then we would have some facility to make this work in SPA type script clients using a code flow, and we wouldn't necessarily need any of the front channel stuff. But I don't know that a fetch API would even accommodate this use case. It depends on what it ends up being, but I don't think anyone's thinking about it specifically.
All right, maybe we should follow up with Anand and Jeff and see what the status of that is.
John Bradley, Yubico. There has been some work on fetch, but the problem that we have doing federation with browsers is that browsers are constantly trying to foil us because they're fighting ad networks and other things. So there are probably going to be limitations in the origins that you can specify with fetch to include as the referred token binding value, which might be limited to the origin of the JavaScript, etc. So the likelihood of the browser being as flexible with being able to do referred token binding in fetch as a native app is somewhat smaller. We may need to, for single page applications, we may actually need to also look at other options using web crypto possibly. There aren't any other good options. This is probably the best, but again, browsers may not be as cooperative as one would hope.
So that's number 5 here. Other ideas.
So Brian, so 1 and 2 would be a little bit unsatisfactory for a document. So like we couldn't figure it out, so let the reader figure it out kind of story. I was wondering whether you also played with the idea that maybe token binding in the implicit flow is maybe not a good thing that goes to get out too well. Is that
So
the
that's
remove support?
That's number
subscription?
4. Yeah.
That's number 4. Okay.
So we did for different but maybe similar reasons in the MTLS draft, basically came out and said this isn't supported, it doesn't work. You shouldn't try to do it binding access tokens to the client certificate when for implicit flows. We could maybe do the same here, which is just take that out, provide some explanatory text or not,
Right.
just have it unsupported. Which is sort of where I was going with this when I started making the slides. That was my idea that I thought I was going to push for. I'm not so sure now because of the note underneath that basically noting that JavaScript clients can't really send the referred token binding ID to the token endpoint. So if we took away, short of some changes in the API that may or may not happen in the fetch spec that may not support it, if we took away, given everything that the way it works now, the APIs that are available and the standards that exist, if we take away token-bound access tokens for the authorization endpoint, we basically exclude JavaScript-style clients from doing token binding at all.
That's true.
So that would be a consequence of that. And I don't know if that's a acceptable trade-off.
Question, Thorsten. The statement is true if you assume this JavaScript clients always use implicit, right?
Well, but that's
Because of the third, so you can't do the token binding using fetch. Okay.
right. So you can do code with JavaScript clients, but the way token binding works, what's provided with fetch now, you couldn't do a token bound access token through the code flow in a JavaScript client.
So Brian, how do you think we should sort of make a decision on that? It sounds like a somewhat unfortunate situation.
Yeah, I don't know. At this point, I just wanted to raise some of the issues. I mean, in all honesty, the future sort of validity and usefulness of this draft itself is somewhat in question at this point. And I don't know how much time we should invest in trying to solve problems like this that in practice may never actually come up.
So Thorsten again, so this your conclusion is we can't protect SPAs using token binding?
Kind of.
I just want to understand.
I'm not sure it's that black and white, but it's very difficult. And right now, given the way things are written, if your browser supports it and you're willing to go through the awkwardness that we've described before in Flow 3, you could do it with implicit. But that's a lot of ifs. And otherwise, then no, you can't.
So Ben Koenig, is the question, can we not currently do that? Or is the question, can we not ever do that?
Yeah, it was a little bit of both.
Well, it depends a little bit on what browser vendors actually come up with in the future, right?
It does, yes.
Which we don't know, of course.
We don't know, but it's not a promising landscape right now. And for some of the reasons that John mentioned, even if there's a lot of support from the browser vendors, what they came up with might not facilitate a nice cross-domain type of use case because of all the issues and concerns around tracking.
Dick Hart. So are you saying there's not use for token binding for other clients?
I don't think I'm saying that.
Well, you're saying, well, I got up when you said, doesn't seem like this draft is useful, but it sounds like it's maybe not useful for native client or browser clients, but there's lots of other clients, many other types of flows where.
Yeah, so it would be, I think there's still potentially a lot of use for other types of clients, particularly native clients or even web server type clients. I am making a bit of a leap that may or may not be proven true, which is without strong support from the browser vendors for the functionality, it's unlikely to see really widespread API support for this stuff in programming languages and platforms, both on the client side and the server side, because I don't think the incentive structure to build that stuff is really there, in which case, even though it's useful for those types of clients, I'm not sure it's ever going to be practically possible to do that development. That said, that's just my expectation and opinion. The question at hand here really is more about what, if anything, to do about JavaScript clients itself, given the state of the specs and what you can do and can't do.
Sure, I understand the limits from the JavaScript clients, but there's lots of other clients, and maybe something different should happen. Need to do something different for JavaScript, but maybe all the other clients. But you're thinking you don't think there's going to be value. Which piece do you think won't happen if there's not support from JavaScript?
I don't think Java and Python and Node and those sorts of environments are going to build the APIs to support doing token binding either from the client or the server side, which renders it pretty ineffective. But that's my opinion. I don't know.
Brian, would there also be an issue in native apps because you are bouncing back and forth between sort of the browser sort of built into the operating system and back to the native app? Would that be a negative, or sort of, could there be an impact as well? So if I only want to build a token binding based OAuth implementation on a native app, would that be then impacted by some of the developments in the browser APIs? Or?
Not directly.
Okay.
The way things are segmented, you can do all the binding and use of the tokens through the interaction with the token endpoint. So it would still be possible, presuming that the platform you're working on allows you to do that. You seem unsatisfied with that.
Well, you're sort of saying that this isn't going to happen unless we have support for JavaScript, and I want to poke at the value we get in a number of other environments. You know, like a native app. You know, gobs of native apps, tons of, you know, just devices, you know, where we're able to do a proof of possession like flow and enhance the security of OAuth without having to go and do proof of possession right into OAuth itself.
Yeah, I agree. And that's why I've been interested in working on it a lot. I'm not real confident about that future right now. It's not for lack of value, but for lack of incentive structure around implementation and making this stuff available.
Lucy Lynch. So I lean towards the remove it if it doesn't work for the JavaScript piece of this. And in terms of your incentives, there's a market forces argument here that if it's important for it to work in JavaScript, that someone else will push the browser vendors. And it isn't this draft that's going to do it.
No, it's not. That's true.
John Bradley, Yubico. So I believe the authors believe that the other use cases are actually really important, and this use case would be really important. The question I think Brian and some of us have is, can we actually achieve critical mass without broad support in the browsers? So are people actually going to update their TLS implementations to support exported key material? What happens when boring SSL removes token binding support? Is Microsoft going to pick that up in their branch of Chromium, etc.? So there are many things still in play, but you know, people tend to put time and effort into things that they think are going to succeed. And right now there are questions about, you know, how broad the support for token binding is actually going to be if it's only perceived to be in one browser. You know, the other browsers, you know, I believe that, you know, although Google may be removing it from Chrome and Chromium, there are people of different minds inside of Google still for various enterprise use cases. So it's not entirely a done issue. And you know, some browser vendors have said yes, it's on. Other browser vendors have said yes, it's on our to-do list, but we have a million things on our to-do list. Show us people demanding it, and we'll get around to it. So it's really a matter of perhaps when we can get that critical mass. It's probably not going to happen as quickly as we had once imagined. That doesn't mean it's not going to happen. But to Lucy's point, if we can't reliably tell people how to do it from JavaScript apps, we should probably not hold out the illusion that that's a practical thing in the short term. We should remove it and look for other alternatives, but we should continue on with the other types of clients where we do have ways of doing token binding. We can do it. Certainly the Windows 10 platform supports it well. And Tony points out it does have Visual Basic support. So, we could probably just declare, now that it's in Visual Basic, we can declare success and all go home.
My fears were misplaced. I apologize.
Stand corrected. So we stand a better chance of and it's still in boring SSL and other things that could make it work on both iOS and Android, assuming those libraries continue to be supported. So if there is a will to make it work on those other environments, then certainly we can do that. There's nothing that's actually standing in our way.
I'm leaning towards removing support for JavaScript clients now and working towards alternative mechanisms. I assume we need browser vendor support for that to happen, either in the Fetch API or something like that. But we should definitely do that, because there is, as far as I understood, no dependency on the response type. It's just the environment that the client runs in. So, and my assumption is for JavaScript clients or any kind of client that runs directly in the browser sandbox, we need browser vendor support. Following up on the question that Dick asked for the other clients, we can pursue this draft for the other clients, but I would like to state the obvious, right? We've got an alternative for all other clients, right? For native apps and web applications. John, you can reflect on my comment afterwards, but MTLS solves exactly the same problems. It gives us proof of possession, and it just works. It's based on mature technology that's out there in the field, and you can do a token binding with it, and you're done.
Annabelle Backman, AWS. I wonder how much the focus on browsers and the JavaScript and whatnot is a little bit premature, in that it's hard to imagine people clamoring to use token binding, given how much of the rest of the infrastructure just isn't there to support it. We don't really have TLS stack supporting it. We don't have web server applications supporting it. We don't have infrastructure supporting it if you're getting your TLS terminated somewhere not your end host. So it seems to me we should be thinking about how do we get those pieces of the system up to where people can start playing with this and experimenting with this and implementing this, because I think that's the big blocker here. Right now, it's incredibly hard for somebody to just start playing with this and discover, hey, this is really cool. Why isn't Chrome supporting this? I'm going to go yell at them.
That's certainly the different way to look at it. Having spent a lot of time on it myself, having it readily available in a client that's widely deployed, I think makes it possible to play with in some environments. And I always felt like that would be sort of the leading edge to drag other pieces of infrastructure and functionality along. It's really, really hard to find the incentive to build in the support in a TLS terminator when nothing else does it, because that alone won't do anything. The same is kind of true for a web server. So, well, if those things were in place, maybe that would help incentivize, but I always sort of viewed the browser support as sort of leading the push. And without it, it's hard for me to imagine those other pieces falling in place. I don't know. I've invested a lot of time in it. I hope I'm wrong, but I'm struggling with seeing how that'll play out.
I guess I think the emphasis is a little bit unbalanced in that, like, in order to make any of this work, you have to have kind of the full end-to-end story. And right now, we really have only talked about one relatively small piece of it. And if you're a service provider on the web thinking about, hey, how would I implement this? You look around and you realize there is nothing in place for you to start playing with it. Like, you could spin up maybe a toy application that plays with it in the browser and talks to one web server, and you custom build a whole bunch of crap to try and glue it together. But that's not going to get you very far. It's not really going to convince you that it's viable to the point where you're going to pursue and talk to your vendors and say, hey, why aren't you supporting this? So I guess I'd say it's not that the browser side isn't important, but we probably need to be thinking more about the full picture and how we get more elements in place.
Okay.
So maybe, so after this longer discussion, maybe it's time to ask the room for feedback on whether we should remove that implicit or token binding for implicit flow for the moment and provide a justification of why it's not there. I think that's what I see where the discussions are currently leaning to it. Dustin. Is that okay for you?
Thorsten, I would like to suggest that we postpone that decision.
Okay.
Until after my presentation, because I will come back to that topic in the security BCP presentation when it comes to implicit grant.
Fair enough.
Yeah.
Let's do that.
Yeah, that's fair. I don't think we have to make any decisions right now. I just wanted to raise the issue. I feel like it's sort of 1, 2, or 4.
Okay.
But yeah, all right. Next and last slide, I'll get out of here. So looking ahead to Prague, one of the questions here was take some action on the aforementioned issue or not. It's sort of an open issue right now. Maybe we just want to think about it for a little while, at least raise the issue and have it on people's mind, because I'm not sure it was necessarily apparent without spending some time looking at it. So hopefully it's a little more obvious now. I just wanted to mention I'm not going to make it to Prague, so you won't have to hear me do this again, at least then. I got family vacation, which according to my wife and my family takes precedence over hanging out with all of you lovely people. I know. Last time I chose you all, I got in a lot of trouble. So, and then I guess I was going to leave this with what we really need here is implementation experience and feedback, and that's the area where I'm really struggling without the support from platforms, from TLS terminators, from TLS stacks, from client-side libraries, from web servers. Without that support, there's really not a viable way to do implementation and get feedback on it. And a lot of what we're doing is talking about it in the abstract. And I say that as someone that actually has done implementation. It's a real pain in the ass given what's out there because you have to do a lot of it yourself or you just can't do it at all. And that's where we are. Dick?
Yeah. On that, I think it'd be useful, and maybe building on what Torsten's going to talk about, for us to go out and talk about what implementations need to be done to make a number of the proposals we have, so we can get an idea around, not just from a protocol point of view, but what are the blockers of like where do we need changes made in certain kinds of code that's out there in order for stuff to happen. I think that could help us in evaluating what might be the most pragmatic path forward on solving some of these problems. Well, architecturally, there might be a preferred solution when we put our pragmatic hat on around what has to happen to enable it. That probably provide us a bunch of guidance. So I would just take that as a work item for the list as we pick up on what Torsten's talking about and compare and contrast these.
Yeah. Torsten's stuff is going to be much more pragmatic and near term and actionable. So maybe it's a good transition into that. Thanks, everybody.
Okay. Yeah, thanks, Brian. So we'll give it another try with my laptop. Hopefully this works now. Can you? It's showing the screen of the wrong laptop. Do you know how to switch it over to the other one? Okay, apparently I know. That's okay.
Thanks. Good morning, everybody. My name is Thorsten Lodderstätter. I'm with yes.com. And I've got the pleasure to present you 3 presentations in a row. I'm going to start with the security BCP, followed by the JOT secured introspective response, and we're ending with JARM, right? Yeah. Just reflecting on what Dick proposed, I mean, we could set together here in a side meeting and talk about what our joint picture is on how token bound stuff could work. That would be, I would strongly prefer that. All right, security BCP. I would like to present you the current status and the development that has taken place since Montreal. Can you turn the monitor on, please? The security BCP enhances the OAuth 2.0 security threat model and security considerations, and discusses threats that had been seen in the wild since OAuth 2.0 was published in 2012. And along with the discussion of the different threats and potential countermeasures, we also distilled a set of recommendations that complement the security considerations in RC 6749. So that's just, oh, thank you. So just to give you a feeling, this is the set of recommendations we came up with and that we strongly suggest to any implementer of OAuth to take into consideration. They mainly concern the way the redirect flow is being used in OAuth, and as we all have learned in the course of the last years, the redirect flow is the source of most of the issues we have seen. So token leakage, wire referrer header, open redirectors, mix-up, accessRF, and so on and so on. So that's a point we focused on. I won't go through all the details. So if you want to get all the details, please read the draft. I would like to focus on the new stuff that we have added in the last couple of months. So beside all the redirect-based stuff, we clearly state that we recommend any implementer of OAuth, and that's something we have heard in the previous session, to use TLS-based methods for binding any access token to a sender. We're not saying token binding because you could use token binding, you could use mutual TLS for OAuth for that purpose, but we strongly recommend to use this kind of proof of possession in order to detect if someone wants to replay a leaked access token. And we also added to the draft some text on access token privilege restriction. This is more or less giving the recommendation to use audience restriction for any kind of access tokens, plus to restrict the action that a client is allowed to conduct with this particular access token, which will prevent any kind of privilege escalation. I mean, in the end, it's good security practice or that has been good security practice for some time, but it never was specified in an OAuth spec. So we added that. And we also put considerable time in analyzing how we could secure the implicit grant. And that's why I would like to come back to the topic that Brian just discussed. Basically, for the authorization code flow, we could use PXE or nonce to detect injection and replay. For the implicit grant, just due to the fact that the access token is directly issued in the front channel from the authorization endpoint, there is no way to use one of those established mechanisms because there is no exchange of a temporary credential to something. The access token is directly being issued. So the only option we have today to really secure that flow is token binding. And that's why I asked Brian to give his presentation first, because he clearly illustrated that token binding right now is more or less an academic option. It's not really a practical option that can really be used in a deployment today as we speak. And there are potentially other options, but they are all in a really, really early stage of adoption. So JARM is one that I'm going to present afterwards. And that's why we came up with the recommendation, and that's something I would like to discuss with you guys. That's the recommendation from our perspective, from security BCP perspective, is to not further use the implicit grant, but to use the authorization code instead on all kinds of front-end browser-based redirect flow. Because the authorization code flow can be protected against replay. OpenID Connect clients can use other mechanisms such as hybrid response types, but for plain vanilla OAuth, we would like to publish the recommendation to the broader audience that the authorization code flow is the way to go. And yes, we have to answer the question how single-page applications could be implemented. We had a session about that at ILW as well. And our perspective is that SPAs can be perfectly be implemented using authorization code, because in the beginning, and that's what people need to understand and remember, the implicit grant had been invented in a time before CORS, cross-resource or region sharing. Thank you. So in the beginning, JavaScript clients were not allowed to perform or send requests to any host outside of their region. Thanks to CORS, that's now possible, which means that a JavaScript application can send a request to the token endpoint. So we can use the authorization code flow for that. There are some greedy details that we need to answer. So John came up yesterday with the browser cache management and so on. But we think we are quite confident that's the better way to go forward, because that's the most robust way. And I would like to get your feedback on that.
No, to everyone.
Everyone.
Like
So Dick,
it's a fairly big recommendation in some sense.
I mean, I can translate that, Dick. Huh? I'm saying get rid of the implicit grant. Do you agree with that?
Annabelle Backman, AWS. Yes. We actually there was a panel at IIW a couple of weeks back where we talked about JavaScript applications and OAuth and best practices around that. And one of the things that came out there was, if you don't have to use implicit grant, then don't. And we talked a lot about ways that you can use an authorization code approach or other ways you can design around that problem. The general consensus was no one likes it. No one thinks it's a good idea.
Thanks.
For Justin Richer, he supports this. And to add to Torsten's point, goes even further. You can set headers in JS now and a bunch of other things. And as myself, Matthew Miller, I say kill it with fire.
John Bradley, Yubico. So the conversation that Torsten and I have had, really, to be precise, what we're talking about is killing the token response type. So the language in the spec around implicit is implicit and not really explicit. So almost everybody has a different notion of what the implicit flow means, whether people do native apps and try to do the implicit flow because they think the spec implies that if it's not a confidential client, you must use implicit. So eliminating the code response type, the token response type, but still allowing fragment encoding, probably expanding on how you would do synchronization between a session cookie for the user session and the expiry of a refresh token. There's a bunch of issues that people have for single page applications that if we're using the code response type, we really do need to dig into and explain to people how they can address the same sorts of things using the code. But it would be getting rid of that particular, token only response type, which I believe pretty much everyone thinks is a bad idea. The response type being a bad idea, not the getting rid of it.
Relaying for Aaron, +1, and the new draft, which he could present tomorrow, recommends dropping the implicit grant as well.
Ben Kaduk as irresponsible AD. So do the chairs need to be asking for volunteers to write a implicit flow die draft that actually writes these up?
I don't know.
I don't know how to proceed with this kind of stuff. I mean, we are basically saying that RFC 6749 is, or we remove something from the core specification. I don't know how to proceed with that. I mean, we could say that in the security BCP.
Maybe that's enough to begin with,
Yeah.
to have the BCP recommend against it and give rationale for why, before we go to try to update or some deeper into the actual 60, whatever it is, the core OAuth spec, having the BCP just
that makes
explain why not. It might be a more measured approach. I don't
Potentially
think we're in a position to
also-
just make it die right now, but to begin its phase out.
Yeah, potentially we can add, talk to Aaron to post an article on OAuth.net. Would be.
Yeah.
Mike Jones, Microsoft. I was going to recommend essentially the same thing as Brian, that I don't think we should try to kill something. I think we should describe security considerations about when you do and do not want to use the feature, which you're already doing, so thank you.
So, but let me ask into the room the question to confirm, at least at the meeting, on whether the proposal by Thorsten is actually the way forward. So please tell me if you agree with Thorsten's recommendations to recommend the use of the authorization code instead of the implicit flow. Now. And how many of you disagree with that recommendation? I don't hear anyone. So I would say it was a very strong preference to follow what you recommended, Thorsten.
Just for the record, there was one hum in favor.
Okay. On Java.
Okay.
You have the clicker.
Oh,
Can you move on to the next presentation, because that's it for the security BCP? So we're going to modify the security BCP and publish a new draft. Okay, next topic. We today have a OAuth token introspection RFC, which allows a resource server to query the data associated with an access token with the resource server. And what we propose with the new draft JOT secured introspection response is, as the name suggests, to add another response mode, which provides the resource server, instead of plain JSON, with a JOT, which in turn allows to sign and also encrypt the introspection response. Basically, the motivation is there are some use cases I'm working on, for example, that are high assurance, for example, electronic signature creation, which require the resource server to get some non-repudiation from the AS. So the AS takes liability of the data that provides the resource server with fulfilling a certain request. And there are basically two ways to implement that. Either the AS issues a signed JOT as a structured access token, then you have the signature, but that's not always possible, especially in situations where you have an authorization grant which allows the client to access different services. And then you potentially do not want to have a token that contains all the data for all the resource server, because this has some privacy implications. So what we want to achieve is that a client can obtain a handle-based access token, use that kind of higher service that has a high assurance level requirement, and this service then call back to the AS and use token introspection to get this signed introspection response. It works straightforward. The resource server is supposed to use an accept header of type application JWT to actually request the JWT formatted response, and the AS answered with an JWT. Where it's getting tricky is at the request processing. So the AS determines what algorithms to use and whether JSON or JWT is being used, but the RS may set up a configuration. That's not necessary for pure signing responses. It's sufficient for the RS just to send the accept header JWT, and then the RS is gonna use its key pair, one of its key pairs, to sign the response. If the RS also wants encrypted response or certain algorithms, then it is supposed to set up a relationship, a policy with the RS, so the AS knows how to process the introspection response. The specification uses the same pattern for setting up this metadata as it has been established by the OpenID Connect dynamic client registration. So it works quite similarly, with one single exception, that in our draft we used the accept header to signal to the RS to the AS that the RS wants assigned a JWT protected response, whereas in OpenID Connect it's just based on the client configuration. What has been changed since Montreal? First of all, in Montreal, the working group, or shortly after Montreal, the working group decided to adopt this work as a working group document. So we published the first version as a working group document, and then we mainly changed or enhanced the text around the management of encryption, because it's been raised on the list, I think it was Tony, that it might happen that in the introspection response, token data could leak, which, by the way, is a issue that the original token introspection draft also has. We can provide a solution for that because you either authenticate the resource server, so you are sure that on the other side of the TLS connection is a legitimate party that is allowed to receive the document, or you just set up encryption. And we have added some text that will prevent all kinds of downgrading attacks, so that a client or an attacker could not try to obtain introspection responses that are not encrypted if the client had been set up to just receive encrypted responses. We changed the default signing algorithms and also added some text about claims. So our assumption is that via the introspection response, all kinds of claims, including user data, can be provided to the resource server. That's it. That's the current status. Do you have any questions, comments?
Jim Shaw, August Sellers. Okay, you partially answered my question, but I don't think it's a complete answer to what I want. I'm kind of curious to know why we're not going ahead and allowing a JWT request, using JWTs on the request side as well as the response side, so that we can basically hide some additional information there in the case of things like referrals and whatnot.
So you're asking why we don't use JOT on the request? In the request?
But
Oh,
this
this
is
is-
the
this is-
this
this
is
is-
the
this-
introspection request.
That's the introspection request, so it's a direct server-to-server request typically, or at least it's a request via TLS connection. So it's protected basically. As I said, the signature is mainly meant to add non-repudiation to the construct. The request itself only contains the token, so we could make a JOT that contains the token. I don't see a real benefit for that.
Well, I would also expect that in some cases you may want to put a non-SYN for timing purposes on some systems.
I don't understand this.
A nonce in a request.
A refresh.
Yeah, I understand what a nonce is, but I don't understand what we would achieve by adding a nonce to the request.
Then I can't get a replay out coming back somehow.
Okay.
I mean, I'm worried about potentially cases where it's running around against multiple servers in the backside.
Okay. Did you typically use a nonce for replay detection, right? No? And we rely on TLS to do replay detection in that case. Because we are running on TLS, on a direct TLS connection.
Yeah, Jim, you may need to explain your threat a little bit more, in more detail.
Yeah. Specifically
the multiple server case, which servers?
I'm looking in terms of multiple ASs. So the message goes to AS1 and then gets knocked off to AS2 to actually do the real answer and come back to AS1.
I don't think this. Do you think? Okay, I haven't seen these cases.
Well, I mean, this would be a standard resource owner. The resource owner and the client owner are separate things. So you actually need to refer it back to the client owner, the client AS, to make sure that the client AS still thinks that's a valid access token as well.
Potentially, we use different assumptions here. I mean, the basic security model of OAuth assumes that our S is bound to a single AS and a different ones. So if you want to determine which AS to talk to out of a set of different ASs, you need more than just introspection. You need to somehow determine based on the access token which AS to talk to, and there is no draft in the working group right now that would support this kind of use case. No. We can talk about that later on if you want. We had a discussion about that, but this is a really simple use case. The RS knows which AS is talking to, it knows the endpoint, and TLS is used to protect the communication. So that's the use case we would like to address, nothing more. Any other questions? All right, I would like to ask you a question. Justin Richer had suggested in Montreal that we change the draft, which right now only covers introspection, to introduce a general mechanism to enable JOT-based responses on other OAuth endpoints. And I would like to know your opinion on that topic.
Relaying for Justin Richer, I think it's actually for the earlier point. RFC 7662 requires RS authentication, but is hand wavy about it. This draft will need to be clear that encrypting results to a key fulfills that.
Annabelle Backman, AWS. Well, I like the idea of getting responses from OAuth endpoints back as JOTs. I like the idea of having that optional additional layer of security there for us to make use of. One complication I see here is that some of these endpoints are called by clients and some of these endpoints may be being called by resource servers. And that in and of itself isn't a problem until I think you get to the configuration side of things. You talked earlier about a configuration step where the resource server is sort of posing as a client for dynamic client registration, and they have separate parameters governing algorithms and such to be used with what we're talking about, introspection. Yes. So that could get messy if you try and generalize the spec to cover these different endpoints that are possibly being called by different parties, or at the very least, that's something that you'll have to clarify how those parameters relate to one another.
Mike Jones, Microsoft. I'll point out as background something you know, but that a lot of the room may not, which is you already have an OpenID financial grade API draft for signed OAuth responses. That's an implementer's draft, meaning it's in reasonably mature shape. Given you've already done that for general OAuth responses, it's not clear to me that also doing so in this draft makes any sense. And as Annabelle points out, there's some nuances about the different endpoints that, among other things, may require different key declarations and different kinds of specifications about what the two parties are willing to do that I don't think we should try to gloss over in a general way.
Yeah, I agree. The colors are completely different. So you will have different configuration models, different security models. I happen to present the other draft in the next presentation. So we can then potentially have a discussion on the list. Yeah.
Really, for Justin, again, unless Torsten does cover it more, this is for back channel. JARM is for the front end channel.
Okay. So potentially I should post on the list, or I will post the question on the list so get more feedback from the working group.
And then there's also the other presentation you still have, which may shed some additional light on that topic.
Yeah. All right. Next presentation, please.
While he's doing that, this is Brian Campbell from Ping. I just want to throw my 2 cents into that. I think trying to generalize it in one draft across all types of responses would be, to use your wording, maybe more academic than valuable in nature. And I would urge caution before we try to do that. I don't think there's really a good use case for it in like revocation responses. The token endpoint, I think, is kind of suspect. And having something that's very different for an authorization response, I think it makes sense to have that completely separate and not try to use a completely sort of generic framework for the two. So I would be against trying to generalize it in that fashion.
Okay.
Thank you for your feedback. So in my third presentation today, I'm going to present a work that's being done in the FAPI working group at the OpenID Foundation, because I think that could be of general interest for the OAuth community. I've written the draft together with Brian. As a kind of a bit of introduction, there are some use cases where we would like to have a signature over the authorization request and potentially response, depending on the threat model and the API we are going to serve. And we already have a solution for authorization request, which is the judge secured authorization request, which is, I think, should go into the RFC queue as we speak.
Yeah, no, that gets
No.
Will get published. So it was just a secondary issue that
Yeah.
we are going to sort out.
Just administrative. Okay, but we are nearly done with that. But we don't have something to sign authorization responses yet. You might ask the question, is there really a need for that? If you look in the wild, you will see, seems like that. Because especially in the open banking area, there are use cases where OpenID Connect and hybrid response types are used to create a signature over the authorization response. It basically uses the ID token and the response type ID token as a detached signature, which works. It provides integrity and authenticity for the authorization response, but it creates some issues because you somehow lose the ability to use real OpenID Connect to obtain user data. And that's the reason why within the financial grade API working group at the OpenID Foundation, we decided to come up with a new draft that more or less describes a pure signature over the authorization response without this coupling with an OpenID Connect. And we called it JUT Secured Authorization Response Mode. Why it's called mode, I will explain in a second. But let me first start with the basics. The idea is in the same way as for the JUT Secured Authorization request to carry all the response parameters in a JUT. And we've also put some extra data in there to further improve the protection of the response. And this JUT then in turn can be signed and optionally encrypted. In the first version of the draft, I made it a new response type. I think I called it signed_code or something like that. And then Brian came up with the proposal, just let's make it a response mode. And the difference is the response mode is a spec, I think it's also in the OpenID space so far, which allows to have different representation for the same response type. It's being used, for example, to introduce a post method, form post method. Thank you, Mike. And we have built up this functionality and introduced a set of new response mode values, which allow to carry response parameters for the different response types. So you could use JARM in combination with code, implicit, or we no longer need that, hybrid response types, and so on. Annabelle?
Annabelle Backman, AWS. I'm going to be a pedantic jerk here and say that you mischaracterized response mode. It does not define different representations. It defines different transport mechanisms. The three response modes that I'm aware of having been standardized are query, fragment, and form post. The representation of the response in all of those is as a URL encoded, query string basically. But it's where it's being placed in the request is what's going to vary between them. I agreed with wanting to make this work with any kind of response type. I think it makes sense to see this as sort of an envelope type, but so my question for you, right, is are you mandating as part of the specification that the JOT is transmitted via a particular manner? Is including the JOT as the query string part of this, or including the JOT as a form post part of this? Because I don't think you can call this a response mode if you're not also mandating something like that.
That's why I said we have different response mode values. The JOT can be either in a fragment, can be transported via form post, or as a query string parameter.
How is that specified?
Just a combination of JOT point. I think it starts with the representation just as query, period, JWT, for example.
So are you using the multiple response modes for that? It sounds like you invented something different.
It's based on the multiple response type.
But it's not, okay, so you're encoding that this is a format.
This is a JOT which is
response
transported via the format post, the form post method. Yeah.
Okay. I think I need to look more closely at what you're doing, but I'm
please give it
not
a
quite
read and
convinced.
give us feedback. I mean, this is the reason why I'm presenting this here, to make you aware there is some work, and it's still in the early stage, even if it went through implementers draft already. So please give feedback on that. Yeah. Right now, it's best to give feedback on the fabulous, because that's where this draft right now lives. All right. So just to give you an example of how this would look like for code, in bold you see the well-known response parameter. So you've got the code, you've got the state value, and in contrast to the ID token, everything is kept within the JOT. Because this is newly designed, there is no need to have a detached signature. We put everything into the JOT. And then we also have the issuer on the audience. The issuer is needed in the end to determine the key material that's being used to verify the signature, but it's also very helpful to identify the sender of this JOT, which is also a prerequisite to detect mix-up attack. And the audience also adds to the mix-up prevention. That's how the request looks like. So you can just use response mode JWT. In that case, the default transport is used for the certain response type. So for code, it's query parameter. For implicit, should be fragment. But you can basically specify what you want to achieve it by adding a period and the transport mechanism. And the response just contains the JOT. That's it. And the client then is supposed to first decrypt the JOT and check all the different values within the JOT, starting with the state. So verifying the state ensures that the request was really also issued on the same device that the response is being processed. So that gives basic CSRF protection. And that also helps to detect injection. So there is no need for additional mechanisms to, for example, detect a code injection. And audience and issuer are being checked in order to detect mix-up, for example. Yeah. What the JARM draft provides, the JARM draft provides a different mechanism. It provides signing encryption, as I said, which also means that there is confidentiality over the data of the authorization response, something we didn't have before. We've got sender identification and authentication. We've got audience restriction, protection from replay, leakage, and mix-up. And this all packaged in a single mechanism. So no need for additional PXE, nonce, or something like that, which I really like with the draft. What I personally also don't like with the draft is that it somehow feels a bit like SOAP XML stuff, adding this to the response mode. Yeah, that's my personal impression, Brian. Yeah. I just wanted to make you guys aware of that, and I would like to know whether you think it's worth bringing that to the OAuth working group here and potentially making that a OAuth specification.
Annabelle Backman, AWS, again, now armed with 30 seconds of having looked at your draft. I do think it's worth pursuing this in OAuth. I think the subject matter expertise is more likely to be found in this space as far as understanding how to do this in a way that is going to play well with other specs that may come along. A couple concerns I see with the way you're doing things currently is you're defining sort of a cross product of two values, right? Which means anytime you get a new value for either one of those things, you have to have a new spec to, update and add the additional cross products. Another approach would be to look at this as a response format parameter, which feels a little bit weird because it's like reinventing, it's essentially doing what the accept header is doing, except we don't have a way of applying the accept header to, say, the query string. So we kind of need to fill that gap.
Just a question, are you proposing then to combine the response mode with a new encoding parameter? Or?
I think response type, response mode, and response format are potentially three different things entirely. And any mixture of any different values for the three of them may be worthwhile. But it's also getting very pedantic and potentially very confusing. So weigh that against everything else. The other concern I see is that one of the mistakes that we made with JOT requests is that we made the assumption that there's no collisions between JOT claims and request parameters. With the result being now that we have to be very careful about making sure that that remains to be the case. And we've had discussions in this very work group where that was a problem, and now we have to figure out how to solve it.
Oh yeah.
Is it worth taking a different approach here where rather than putting the response parameters in the JOT root level as where they could collide with JOT claims, do we instead want to define a JOT claim for an object that would encapsulate the response parameters?
So you would like to separate the metadata from the actual
if we had a
payload.
response, and then the value of that being an object with code and state, something along those lines, is I think worth considering, given our recent experience with JAR and how that's played out, colliding with I think specs from other work groups as well. So,
thank you.
Relaying for Justin, so remember where to throw your arrows. He's not against this work coming to the group, but would like to generally ask, how much of SOAP are we going to reinvent before we admit that we've bastardized HTTP in a horrible way?
Since we do
Mike Jones, Microsoft. I think the way to handle the potential collision between JOT claims and request or response parameters is simply to augment the instructions to the designated experts for the relevant OAuth registries, saying be sure to avoid pertinent JOT claims in those registries. In practice, the signed request format has been a standard since 2014 and has been in production. So we're not going to touch that. And I believe that, this should use the same modality, which is the simplest thing is you put all the claims in the top level. I'm against complexifying things when it's not actually needed.
So Matthew Miller speaking for himself. I think, and also after about 30 seconds of looking at this, it's very interesting, but I think the fact that there's so much discussion happening this mic means that maybe this work ought to be happening here to cover some of these cases that seem to be cropping up with this audience, even if there is a tremendous amount of overlap between OpenID Connect and here.
Annabelle Backman, AWS. I think it as far as how do we handle putting the response parameters into the JOT, ultimately, I think it depends on what you want the scope of this to be. If you want this to be something that is used within the OAuth space, in our specs, and nowhere else, then yeah, you could maybe get away with saying, hey, just make sure that your response parameters don't collide with JOT. If you want this to be something that is more broadly adoptable, such that it could be employed with as a response format for other protocols that already exist out there, or anything that people might be building in the future, where avoiding collisions with JOT claims may not necessarily be practical, then I think it's worth avoiding that problem since it's easy for us to do so.
I think this is especially the case for pre-existing protocols, right?
I knew I was going to say something else, Mike Jones. I've seen in practice that people already, developers, get confused and do things wrong, given we have the combination of response type and response mode. Despite the combinations all being well-defined, I've seen implementations not follow the specs. I really, really don't want a third parameter called response format or something, which you would have to understand all three values and the combinatorial permutations thereof in order to know how to encode requests and/or responses. I think developers will certainly get that wrong too much of the time.
This is Brian Campbell. I guess I'd like to agree with Mike, although I appreciate the pedanticness of Annabelle. I do want to read the definition of response mode is the response mode determines how the authorization returns result parameters from the authorization endpoint. So I think that what's being done in here is well within the definition of that, although it's sort of mixing the encoding and the generalized format of it. I think it's close enough to satisfying it, and the possibility of introducing a new format versus mode versus type could really add a lot of confusion. And the possibility of sort of the combinatorial explosion, I think, is there, but in practice is very unlikely to play out in a bad way. So I would very much like to keep it as a mode. As far as the collisions go, I don't know what to do. The only practical collision we've had is around odd in the JWT request that came up. It was specified in a standard that's still out there. So it's, in some ways, it's sort of an academic collision. We've only had one actual instance of it. And another way that this could deal with it is registering those parameters that are meaningful in JOTS in this context so that they're taken as response parameters. I don't really know if that's better than creating like a submap. I think a submap might be a more elegant solution, but then then it's sort of different than what we're doing in all the other ways that we're doing this. So
Yeah, it's especially different from the way the response works, and that's
exactly.
Yeah.
If we could go back and do it all over again, I think having that sort of separation between meta info in the JOT and sort of parameter info in the JOT would be valuable, but we don't.
Let's call it envelope.
Envelope. I don't think it's as soapy as everyone's saying. I think it's just useful, but maybe I'm in the minority there. I do have I don't know how to say this. I have a little concern about introducing this work here because we've struggled with sort of dual track specifications in the OpenID Foundation and here when we try to solve the same problem and we end up with almost compatible but somewhat different things that do the same thing. And not to say that having the input and expertise of this group wouldn't be useful, but I'm really worried about coming out of that with two JARM specifications that do the same thing in different ways and aren't compatible with each other. So I don't know what to do about that, but it would be a concern.
I understand that. I mean, we started the work in FAPI because there was a direct need for this kind, but it's obviously something that could live in the OAuth working group as well. And the question was raised in the beginning in the FAPI working group as well. So I don't have a solution for that, and I would like to come up with the same specification, just one working group referring to the other.
Wherever it is, I'd like it to be just one. That would be my hope. Thank you.
Mike Jones, 2 comments. First, I'd like to agree with what Brian said as the primary author of the response mode specification, that the use that you and Brian are putting it to is within the conceptual scope of what the response mode was intended to do. Second, I just wanted to provide background information for those of you who may not be also in the ACE working group, that the one OAuth parameter conflict that did arise, Ludwig Seitz fixed in his OAuth parameters draft, which was submitted a month ago or something. I know Hannes and I have reviewed that, and we believe that that's now sorted out the conflicts. So I think in practice, we're in good shape. It was odd, I think. Yeah, yeah.
It's the same one.
Okay, thank you.
So Thorsten and Brian, I think I heard some good feedback about how this could be of generic use besides just a financial API. So maybe you could write up a draft and then socialize it somehow, since there's a certain overlap of people with the OpenID Connect Foundation. Is that a good way forward?
I don't know whether it's against the, this is Thorsten speaking. I don't know whether it's against the rules, but we could also first circulate the URL pointing to the FAPI draft in the OAuth working group list.
Sure. You
Yeah,
can also
that's
do that.
simpler for us.
Yeah. That's something you can do right now. Yeah. Okay. So, where's the blue sheet? Did you guys sign the blue sheet? Oh man, we have, we're perfect in time, presentation wise, but make sure that you sign. So, next presentation is one that I'm going to give on behalf of these people. At the last IETF meeting, we had a longer discussion on the POP AES to client key distribution. And it was also in relationship to some of the work that happened at the same time in the ACE working group. Mike hinted to that a few minutes ago at the microphone. And we came up after some discussions in Montreal with a couple of suggestions for a way forward. One of the decisions that we took at that meeting was the adoption of the resource indicator document. But there were also some changes to this specification, and then there was this corresponding activities in the ACE working group. The ACE working group meeting is later this week, so we'll capture this one first. So this is sort of the picture taken from the document, just illustrating the classical OAuth stance, augmented with some additional fields, namely this is the resource indicator, the request confirmation, the RS confirmation, regular confirmation, and the token type. We're going to talk about the resource indicator document tomorrow, so I won't spend too much time on this anyway. Skip that. There is the use of these, so there are a few parameters in there, which, or the idea is that the ACE document has the corresponding parameter just for different encoding, namely for use with co-op, and this one is the encoding for HTTP, which is what we agreed on in terms of work split at the last IETF meeting. So the request confirmation is a parameter that is only used for the case when you want to bind an asymmetric key pair to the token. And so this is called the request confirmation. In case of the response for this, in the symmetric key case, the server is actually generating the key pair, or not key pair, the symmetric key, and he needs to send it back to the client, and can do that in two cases or in two different formats. One is either encrypted. It would be in any case encrypted using transport layer security, but the authorization server may additionally encrypt it using a JWE, or it sends it as a JWK in sort of over transport layer security. And so this document now registers, in the IANA consideration section, has the request confirmation and the RS conf, the conf parameter and the token type parameter registered as in the IANA consideration for HTTP. The token type is, the token type is something that we had already I believe, earlier, because it's the bearer token that we initially used it. So we only registered a new value, which is the Bob token type for this usage. Jim, do you have a question on that?
Yeah, I think so.
Okay.
Go back a slide, please. There was one case that we're having some arguments in the ACE group on the request CNF, where we wanted to put a key ID in potentially for symmetric key. And the question that we basically had for the OAuth group is how much of a concept of there is issuing a secondary token with additional privileges on the same key? And is that something we should be doing, or we should be just replacing the token?
So you're essentially issuing, you're talking about issuing 2 access tokens at the same time?
Well, issuing one access token and then issuing a second access token with additional privileges at a later date, but on the same symmetric key.
Okay.
So there is a case where we are talking about maybe putting the symmetric key in the request confirmation as a key ID.
So Mike Jones, follow up to Jim's question. In standard OAuth, the only way to get an additional access token is to use the refresh token, in which case I think it makes perfect sense to key it the same as the previous access token unless an explicit key rollover has occurred. Is that the ACE use case you're talking about, or is it a different mechanism that's not part of normal OAuth?
We were actually looking at doing a slightly different way, but we can basically rewrite to use the refresh token, I think, without any problems.
Okay. I think that would resolve that issue. So there, as I was preparing the slides, I noticed that I still have a few bugs in the specification. I would try to issue a new document based on this, just copy and paste errors. There's also some, the WebRTC guys are using a different token format. So they have come up with their own token format a while ago, which is published as an RFC and which was reviewed by this group. So I think having them review this document obviously makes a lot of sense. And one of the guys who joined as a co-author is actually part of that community. So if Missy, so I probably they have already reviewed it, but it would be good to get a confirmation. We may need a few more detailed examples to illustrate the case. Specifically, currently the document is full of examples that use the JSON-based encoding, but this mechanism can also be used with, of course, other token encodings like the CWT. So there's nothing that prevents it. And this was partially also where the relationship to ACE came from, besides having a sort of alignment with the parameter names when used in co-op, because one possibility is to just have, for example, a smartphone that interacts with an authorization server using regular HTTP, but it actually, when itself talks to an IoT device, it will want to use a smaller token encoding using the CWT. And so it then basically requests the CWT using the HTTP-based mechanism and passes that on. So, for example, at the moment, none of the examples don't sort of illustrate that. And maybe the similar example should be for the WebRTC in there as well, to just give a broader range of deployment flavors. Yeah, and we talked about the alignment with ACE, which we've been sort of exchanging messages back and forth, and some of you are probably also registered on the ACE list and have seen the interaction between Mike, Ludwig, and myself on that list.
And Jim.
And Jim, yeah. Good. Any questions on that? One, maybe I should have put that on there. One open issue that shows up once in a while is currently what the document talks about is really about binding the access token to a key. And we obviously use the existing mechanisms for doing so. It doesn't say anything about what happens to the refresh token itself, which we talked numerous times in a group, and we may need to mention that in some way or the other. Is there anything else that comes to your mind that we need to take into account? Nothing. So that's good. And I believe with this, we are, unless you have some other questions, we are done for today's meeting, and we'll continue tomorrow with the agenda. And I will add one additional item based on Aaron's document submission on the JavaScript-based application PCP. Dick, do you want to go to the microphone or no? Oh, we wanted to talk, we also wanted to have a side conversation and regarding MTLS and the stuff that Eka talked about earlier. So I'm proposing maybe since we could give a brief summary or a brief update on this tomorrow at the meeting already. So maybe we could get together for lunch, if you guys have time. After this session, okay. Okay, do you think we can do some presentation today still?
No, but you're just putting a lot of additional stuff in there. It might be, I'll be quick. Okay.
You will be quick? Okay.
Can you go now, Dick?
No. Haven't made my slides yet.
Okay. Dick, what was the other question? I interrupted you. What was the question? The JavaScript document that Aaron was talking about, I was told that he submitted it and posted it to the list. Is that correct?
He definitely posted it in the Jabber room. I'm
Okay.
not sure about the mailing list itself.
The Aaron produced a JavaScript OAuth BCP document, the first draft, and he sent it to the Java chat only. No. Aaron, Aaron Braddock. The different Aaron.
I was afraid.
Yeah. Matt, maybe you can post the link to the OWASP mailing list. Anything else? Okay. Thank you. Oh, the blue sheet. Give me the blue sheet back.
Ask if everyone signed the blue sheet.
Thank you, Nick. Did everyone sign the blue sheet? Who? Oh, man.
I'll go help.
Does anybody have the blue sheet up there next to them? Okay.
Good.